Good morning, geometry students. Today we will continue with Unit 6, Lesson 6, Theorems 5 and 6. So let's move on with Theorems 5, which states as follows. If a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is going to be 1/2 the measure of its intercepted arc. So let's see what that would look like. In our model, we have a circle and two lines again. They are coplanar, the three of them, which means they have to be on the same plane. So here we have circle X, okay? We have MJ, which represents a secant line, and we also have line LK, which represents a tangent line, okay? Notice that both the tangent and the secant, they are both intersecting at point J, which also represents the point of tangency, okay? So applying our Theorem 5, that would mean that angle MJL intersects arc MJ, and we also can see that angle MJK intercepts arc MYK. So if we were asked to find the measures of both these angles, we apply the theorem and we would have something similar to the following, okay? So in this case, again, we have our circle and we have two lines. One line, which would be MJ, represents a secant, and our second line, which is LK, represents a tangent. Note that both lines are intersecting right here, which is point J, and it also represents the point of tangency. So if we were to find the measure of angle MJL, which is this angle right here, okay? The measure of MJL by definition would be 1/2 times the measure of the arc it intercepts, which is MJ. The same thing would happen to the measure of angle MJK, which would be this angle. The measure of angle MJK would be equal to 1/2 times the measure of the arc it's intercepting, which is MYJ. Okay? So if we were assigned values of the measure of arc MJ, if that measure would be 170, and the measure of arc MJY would be 190. In order to find the measure of angle MJL, we would just use our equation, which is 1/2 of the intercepted arc, substitute the measure of arc MJ for 170, and half of 170 would be 85. We would do the same thing to find the measure of MJK, which is 1/2 times 190, which represents the arc angle MJK is intercepting. So 1/2 times 190 would be equal to 95 degrees. Okay, now we move on with sample problem number 6. We need to find the measure of angles ECB. ECB would be right here. Okay, and we also have to find the measure of angles BCD, which is this one right here. So what do we have first? What does our model tell us? The model is giving us three things. First of all, we have a circle and we have two lines. Notice that one of the lines, which would be line CB, is a secant because it is intersecting the angle at 2 points, which are C and B. We would also have our second line, which is ED. ED represents a tangent. So we have the intersection of a tangent line and a secant line at the point of tangency, which would be point C. That would mean that we would have to, in order to find the measures of the two angles they're asking us, we would have to use Theorem 6, which states that the measure of angle ECB is going to be equal to 1/2 of the measure of the arc it's intercepting, which is CAB, and the measure of BCD is going to be equal to 1/2 of the measure of the arc it is intercepting, which is arc what? BC. Okay? So just substituting the values we have and using our equation, the measure of angle ECB is going to be equal to 1/2 of 230, which is equal to 115, and the measure of angle BCD is going to be equal to 1/2 of the measure of arc BC, which is 130. Okay? Now, half of 130 is going to be 65. Notice also, very important for you to know, and notice that angles ECB and angles BCD, they both form a linear pair. And what do we know about linear pairs? We know that linear pairs are going to be supplementary angles. So that means that the sum of their measures is going to be equal to what? To 180 degrees. Okay? Notice here that 115 plus 65 is going to be equal to 180. Now we move on to our Theorem 6. Our Theorem 6 states that if two chords, now we're working with chords, if two chords of a circle intersect, then the product of the segments of one chord is going to be equal to the product of the segments of the other chord. Notice here, what do we have? We have a circle and we have two chords. We have chords A, B, and C, D. By definition, we know that chords are line segments, right? For which its two endpoints are going to be on the circle. So CD are the endpoints of chord CD, and AB are the endpoints of chord AB. Both chords, remember, I repeat, are line segments. So this is also called our chord rule. So we have the intersection of the two chords in the interior of the circle. So that means that if we take line segment AB is also divided into two smaller line segments, which are AE and BE. The same thing happens for CD. CD is divided into two smaller line segments, which would be CE and DE. So your chord rule simply states that the product of AE times BE, which are the two smaller line segments in chord AB, is going to be equal to CE times DE, which represent the distances of the two smaller line segments in chord or line segment CD. Okay, let's just go ahead and apply this with an example, as we always do. So here we have a circle, and here we have two chords. The two chords are A, B, and CD. We have to find the measure of the unknown segment X, which represents the distance from D to E. That would be X. This is what we have to find, okay, in the given figure. So here, what do we have? We have two chords intersecting in the interior of a circle at point E. This is the point of intersection, okay? Now we use our chord rule, which states that AE times BE is going to be equal to CE times DE. And here we set up our equation according to our chord rule. Next, we simply substitute the values. The distance from A to E is equal to 5. The distance from B to E is equal to 12. That's going to be equal to the distance from C to E, which is 4, and the distance from D to E, which is our unknown variable, which is X. So here we set up our equation. 5 times 12 equals 4 times X. 5 times 12, that's 60. 4 times X, that equals 4X. So if 60 equals 4 times X, in order for us to find the value of X, because we don't want 4X's, we want to know what the value of X is, we simply divide by 4 on both sides using our division property, and then our value for X is going to be equal to 15. Now we have to check if our X value is correct. So what do? 5 times 12, that's equal to 60, equals 4 times our value of X, as we determined, is 15. So 5 times 12 equals 4 times 15, which is what we have here. 60 equals 60, and there we get a true statement. So that means that X equals 15. That's your correct answer. Okay. Now let's finish it off with sample number 7. we need to find the measure of the unknown segment x in the given figure. First of all, we have our circles, and we have two chords which intersect at point what? At point O, which is in the interior of the circle. So applying our chord rule, we state that MO times QO, MO times QO is going to be equal to PO times NO. They represent the shorter segments in the bigger segment, which is equal to the chord. Now we simply go ahead and substitute our values. MO equals 3, QO equals 8, PO represents our unknown variable, which is x, and NO is represented by 4. So 8 times 3, 24, is equal to x times 4, or 4 times x, which is 4x. In order to find our value for x, we use our division property. We divide by 4 on both sides, and x equals 6. Now we want to make sure we assess if our answer is correct. So 3 times 8, which is 24, here 3 and 8, is going to be equal to PO, which is 6, and our new value for x is going to be what? Our new value for x is going to be 6. So 3 times 8 is going to be equal to 6 times 4, 24 equals 24, and that is a true statement. Okay, so therefore, we just completed our chord rule. So tomorrow we will continue with theorems 7 and 8. Have a great day. Bye-bye.